All right, Greg, please take it away.
All right, thank you very much, Melissa. This is really wonderful to have an opportunity to share some of the excitement of the Rubin data. And not only I'm going to show you some of the tools that you can use for the for analysis of Rubin data using the portal, but I hope to show you some of the results actually from some of the early observations. So let me start sharing my screen first. And it's the data discovery that I'm going to be presenting here. Okay, now let me just make sure that this can be viewed as a slideshow. That's a little bit better. Hopefully you can see. Great. Okay, good. So this is going to be data discovery in the portal. And just as you probably have heard from many different sessions that this Rubin Academy is a little different this year. We are going to take advantage not on just merely of the simulated data, but in fact, we do have this commissioning camera data, the data preview one, so you can actually show you some of those products. And again, the hack and networking sessions are now replaced with the question and answer session. So there will be one today after my presentation. And then if you still have some ideas that you would like to explore further, there's one more that you can actually do on the same address. I believe it's today at 6 p.m. California time. There are 10 sessions running in morning and evening. And again, this is for global audience, for our colleagues who are in other countries, such as in Asia, Australia, New Zealand, and stuff like this. Those are the evening sessions. Those are the intended audience for the evening sessions. And again, the site for the Academy is listed here, and I hope that somebody might be able to put this into a chat window, just in case we don't have it. And the slide deck is actually listed there, and this is session number 3. So one thing that just very quickly I will go over at some level over the aspects that are listed here. We're going to talk about navigating the portal, exploring the HIPS maps, and so on and so forth. And the important part is trying to understand how to set up the catalog queries for the catalogs and also for images.
Greg,
yes, please go ahead.
Your slides are not showing up full screen. We're still seeing the whole your whole window.
Okay,
yeah.
fine, great. Yeah, probably one of the reasons why I did this is so I can actually see a bit more of my screen. But anyway, so let's continue with this. I hope that I will have no difficulty with moving on to the next window. Anyway, so this is going to be a very much an interactive session. At the very end, we're going to have some sample science investigations. What I hope to do is to extract and plot a light curve of the active galactic nucleus that is actually an extended Chandra deep field south. And again, we have coordinates for that, and we'll try to see how the flux changes as a function of time, even though it's just a brief 1 month-ish long worth of data sets, you still can see the variability of that. And then I will show the plot of color magnet diagram of extended sources in again in a region of the extended Chandra deep field south. Okay, so one very important general comment that there is a difference between the portal versus notebook aspects of the Rubin Science platform. The portal is really sort of like get you started, get you sort of involved in this very beginner type steps. It's very interactive. There's 2 different aspects of it. There is the user interface, which is even simpler. You can basically choose columns and make choices of the parameters by hand. But you can also, yes, go ahead.
Sorry to bother you. Now there's just a black screen that says loading.
Oh, okay.
Yeah.
Is that better?
Yes.
Okay, so
thank you.
Yeah, let me just expand this a little bit. Hopefully now everybody can see. I'm a bit surprised that there was just a blank screen that said loading, but that's okay. Okay, so anyway, just to come back to what I was saying is that the portal is a way to get things started, to look at the data, to take basically a peek of what you can do with this, what is there. But if you want to do a more advanced work, for instance, statistics, like putting data into some kind of a statistical form or doing cross correlations, then you really need to use the notebook. And in fact, you probably have seen that distinction between the two. So this is just to clarify the fact that those of you who have just starting graduate students or undergraduates even working on your data, get them started with Portal, but get them familiar with the notebook. All right, so there is a fair amount of stuff in the portal, but the vision here is for you to follow along. So let us know if you have any questions or problems. Hopefully, those of you who are online are already have they have data rights, and therefore you can actually log into the Rubin Science platform and select the portal. So while you're connecting, I have a few very quick announcements. One of them, I hope that you can still see Tina, can you see my Rubin Community Forum slide? Hopefully, yes.
Yes.
So any kind of information that you'd like to get from us, any kind of questions that you might have, we'd like for you to use the Rubin Community Forum. This is a place where you can actually post your question that we will attempt to answer as quickly as we can. And the important reason for having those posted in the community forum is that the same question might actually come up in a future, and at least it's a repository for questions rather than having the question go into some kind of a space. And all right, this is just a quick comment about the Rubin data policy. You probably know that data right holders are all scientists and students who are working or enrolled at US or Chilean institutes. And they're named also members of the international in-kind contribution teams. Many contributions from international teams have been submitted to Rubin, and the result of submission of those allows some of those teams to have we call it the principal investigator, basically means data right access to the data. And only the data right holders can access the proprietary data and services. And this is very much true for the data preview 1, because those are really serious astrophysical data taken with the Rubin Observatory. The list of the data right holders is in that link that you can see on a screen. And again, we already heard from many people about the proprietary period, that the annual data release products are going to be proprietary for 2 years, and at that point they become public. But alert packets and prompt catalogs are becoming available more rapidly. But anyway, this is something that you can probably learn from this publication of that I mentioned earlier, which is listed here, which is the publication for the of information for the data. This is this RubinObservatory.org, which is where you want to go to. So if you ever publish anything from the DP1, you have all the relevant information about what you need to do. So anyway, I'm not going to go through this any further. So the portal tutorials can be all listed in this list that you can see up on top, dp1.lsst.io/tutorial/portal. And there's actually some more than the ones that are listed here, simply because we have done this, we have added some more. So just very briefly, let me go through a few key concepts having to do with the Rubin data. So data access to Rubin data is via table access protocol, among others, and it's a standardized access. It's an access, and it's an IVOA standard. And again, this is something that you probably have heard from Yumi earlier on today, but it's available through both portal and the notebook, so it's very convenient. Again, we're using ADQL. This is a very standard astronomy query data language. It's very similar to SQL, and it's at this point basically IVOA standard for querying all the astronomical databases. Okay, so now I'm going to just give you some more key concepts, and I think that this is something that is sort of my own, so I'm going to project a bit on you. For some of us, concept of source versus object is not completely obvious, but it's really important to stress that that source, you can think about it, it's an observation of a particular star, okay? An object is basically a star that has been you can think of objects as being a specific star and source being specific observation of that star. So source table contains measurements in a processed visit image. That's important. So this is just one snapshot. An object table is measurements that are created in deep COAT images. So when you have, for instance, in order to go very deep into the into the sensitivity of the data, you really need to add individual images. And again, for those deep colored images, you do not have any time variability information. On the other hand, if you want to extract time variability information, you really need to work with essentially with equivalent of processed visit images. Okay. Now, one more thing that I wanted to mention here for the key concepts is that there is such concept as forced photometry. It turns out that you might want to study a flux variability of an object that is in a very specific location, but that object might actually go up and down in flux, and maybe it's not even present in some of the observations. So at that point, we actually have a concept of forced photometry, which means that it's a measurement made a fixed coordinate in an image. It's regardless whether the object was above or below threshold. Okay, so this is pretty important that actually we do have that kind of bit of information. All right, so the kind of tutorials that we're going to cover today will be really simple. Again, this is something that I just want to make sure that this is really today's presentation, and also using the Rubin Science Platform's portal is really more for people who want to get started with the data. Not necessarily beginners, maybe people who are very familiar with some aspect of it, of data analysis, but just want to get started on this. Okay, so at this point, I'm going to stop sharing the introductory slides, and I'm going to get into the Rubin Science Platform. So again, I'm going to reshare here. Where is my share button? Here we go. And I'm going to now go into the part of data discovery here. So let me just please go into the Rubin Science Platform here. Great. Okay, now I can go into close this for a second and start sharing again. Okay, very good. So right. So now we're going to share the Rubin Science Platform, and this is when you land at the Rubin Science Platform. Basically, you end up in at something that looks like what we see on a screen here. So we can just quickly review the layout here. Again, you can see that you can access DP1 images via standard image, whatever simplified image access version 2, but you can access catalogs as well, and so on and so forth. But there is more. There is a little icon on the upper left-hand side, which we call the little hamburger icon, and that can add additional tabs on top. For instance, if you would like to add something like multi-archive tabs, which is something that we're going to be using, you can click on this and notice that this appeared all of a sudden on the screen here. So you have those multiple tabs on top. So now to review the layout of this, you can see that not only you can choose that particular display, but there is a bit more in the choice here. There will be additional aspects that will sort of appear here, the layout of the screen, once we get into the more advanced aspects. So let me just think if there's anything else that I would like to show. I think at this point we are dismissing the sidebar, so that's fine. So now one thing that I would like to do is I would like to show you how to browse the HIPS maps. Those are hierarchical progressive display maps, and that will be something that we can actually see again through here. And I think that there should be yes, Rubin HIPS search, and that will allow you to actually look for the different images from Rubin. So let me just click, for instance, on one of those maps here, and again notice that on the bottom lower side there is a search button. So if I click this, all of a sudden you can actually see that particular HIPS map, and this is actually a real Rubin data. You can zoom in and out. I'm going to zoom out, and you will see that the zoom out causes basically display of it just takes a while for it to load. And yeah, this is one of the fields of the Rubin Science observations with the commissioning camera. So let me continue sliding this down, and you will see that there will be all of a sudden other Rubin fields that will appear. So this is basically just a very short illustration of how to use the those HIPS maps. Now, something that you probably already have seen, and just go back to DP1 catalogs. Okay, great. And something that you probably already have seen from Yumi's presentation, that you can actually submit a job, and that will allow you to actually study the content of the job, the progress of this. There's this little tab called Job Monitor. You can see that there is something that right now, of course, I don't have very many jobs running, but there will be, if I started number of jobs, especially the longer ones, you would see number of them here. And there is a little aspect here that shows the search result. And then you can actually, if you choose to abort the job and just get rid of it, you can click on the little garbage can here on the side. Okay, so let me go back to DP1 catalogs, and I think that right now the next thing I would like to do is to start querying for the catalog data. So the way we are going to do this, again, you probably can go to the tutorial 102.1. I'm going to follow that particular one, and I'm going to actually enter some parameters here. But let me just, before we go any further, let me just give you a bit of information about what's going on here. You can actually, in this particular case, you can select the proper table. And again, the default one is the data preview one table. This is what we call a schema. And let me just give you a little bit more of a sense of what this is about. Let me just get rid of this here. If you go to edit ADQL, this is just, I will explain what this is all about, but if you go to edit ADQL, you will notice that on an upper left-hand side, you actually have something that is called a schema browser, which is basically would tell you what is available in a different catalog and what is available in a different table. So if I click on DP1, for instance, notice that there's a whole list of different tables that are available in DP1. And then I can click on individual table, for instance, on DP1 object, and there's a plus I have to click on here, and this will take a while, but this tells you all the entries that you have in that particular tables. Okay, so this is just so you know what's present there, but for the time being, I'm going to just use the UI assisted type thing. So I'm just trying to tell you what is available here. And again, you can select on different columns, and not only you can select the column to be returned via the search, which is on the lower left-hand side, but you can actually provide the constraints for that particular column. So for instance, if I want to have something that has a flags just very quickly as a display that has a flags greater than 360 nanogens, is the something that I would enter here. For the time being, this is just a quick information about what you were supposed to be putting in. Again, the description of the individual on the individual entry in the table is here on the right hand side, and there's a lot more information here that you at some point might want to explore. So let me just at that point just do a query of the very quick information how to extract how to make a query for instance, of images using the OpStep. Okay, so this is going to be now something that I will let me just go query images OpStep, for instance. So that's sort of almost like one of the things that you always want to do to begin with. Actually, maybe at this point, this might be a good opportunity to stop for a second. If there are any questions, please go ahead and ask. I don't know, Tina, are you watching the chat window, or are there any hands raised? I can't quite see.
Yeah, everything's fine.
Everything's fine. Great.
Yep.
Okay. All right. So let me just go back and try to now query for images using OpStep. The way that we'll do this is we'll do it by basically the whole idea here is to visit image to study individual images. Okay, so we can go to DP1 images here. Okay, and the idea for this would be to determine or to extract all the images that contain very specific observation point. My favorite, of course, is the extended Chandra Deep Field South. So I'm going to try to get all the images of that one, and that is something that actually will come up with multiple times in the future. So this is at 53.0 and minus 28.0. This happens to be a location that is within that particular one. So the observation that contains that particular point is what we're going to do. And a very important part is that you need to also select the proper type of observation. So what I'm going to do is, again, just so I come back to what I said earlier, that there are 0 and 4 are not something that we're going to be using here, but the observation types is raw data, and which is level 1. You probably do not want to use that because those data are not really properly calibrated and all that. What you probably will be working with is the individual PVIs or CALEX. PVI stands for processed visit images. So this is, again, one snapshot, 30 seconds worth of data. And then the COADs are the level 3. So let me just go first to the processed visit images that are containing that particular point. Notice that I didn't check timing, spectral coverage, or object ID search. And I'm going to just click on search here. And what you will see in a minute is just at first the display on the left-hand side is something that has been left from the previous search. So let me just close this one. Here, the pinned image, and instead we're gonna use the data product. Again, notice that I clicked on the tab on the upper right-hand side, upper left-hand side, and what you actually see in the display is essentially the first image in a table on the bottom. So this is basically what you get when you come back with when you put any kind of query into the display here. Now, one thing that I want to sort of backtrack a little bit is that you can actually change the layout. The results layout is actually present only once you have the result display. But for instance, if you're totally not interested in the table, you can actually click on the little up-down arrow here, and you can have coverage images and charts only, for instance. And I will do this for a second, and notice that the table disappeared, okay? Again, but what I can go back, and I actually much prefer to have the table on the bottom as well. So let me just go back to coverage images and charts here, actually, or like images and charts, is what I want. And again, I have to go back to the right-hand side. Okay. All right. So now here, the active chart is something that I really will want to have just so I know exactly where my pointing is. So just to explore a little bit more of this image display, you can actually notice that there's multiple of those visit images on the bottom. Each one of them is, again, 30-second long one. So for the data products, again, it's always image, always the image. Calibration level, I selected to be PVI, which if you click on a little arrow here, it will be number 2, since this is something that I selected in my search. And then LSST band here, notice that I did not specifically select a specific band, in other words, specific filter. You can actually choose the filter by basically clicking on this. Hopefully all of you can see this. I'm going to apply this, and notice that now only the images which are collected in the I band are selected here on the lower left-hand side. Now I can click on another line, and that will result on not only in the display of exactly where that image center was pointed, but also the different image will appear here. So let me just go to the fourth one here, and notice that a different image will appear. Now what I can do is I can have multiple images. There will be first 6 or 8 images I think it's going to be 8 images, even though the little icon says that there should be 6. Notice that each one of them is popping up very elegantly on a screen, but they are not necessarily all oriented in the same direction. What I'm going to do is I'm going to click on this little sort of chain thingy that is on an upper right-hand side, and I'm going to align and lock all the options with the WCS. So notice that now all of a sudden, some of them are twisted a little bit, simply has to do with the fact that the orientation of the CCD with respect to the sky has changed because of the fact that the particular pointing was in a different direction with respect to the telescope position on the sky. So anyway, this is just something that I wanted to highlight for you for the kind of images that you can query here. And maybe at this point I should stop and find out if there are any questions. Tina, if you would be kind enough to monitor whether there are any raised hands or any questions.
Yes.
Thank you. That's great. Okay, now one thing that we can do is we can convert that particular query that I'm going to go back from results to the DPY images. Notice that I asked for specifically for Rubin PVIs in a location that is given here. Now, maybe because before I go any further, maybe what I can do is I can also ask for only observations that were done during certain period of time. Okay, so I'm going to ask for the observations that are completed within a specified range. Again, the convenient thing to do is to put it in MJDs. We know that we are running at roughly at about 60,000. So let me just do it as 60. I think would be 600 to 650. I think 600. Okay, that's better. 6650. And now I am selecting the images that are only collected during that period of time. And I hope that I remember that correctly. But notice that the number of images is now 482. If I go back into the images and uncheck the timing, I perform another search. So I correctly restricted the amount of the window of the observations. Notice that there are 783 observations here, and in the previous one we had on the order of 400. So this is just another yet place where you can actually put some kind of constraints into this. So I'm just trying to think what would be good. Oh yeah, the important part is that what you can do is you can convert. You probably have seen it in Yumi's presentation, but you can actually convert the ADQL. Sorry, the search from my images into an ADQL search. And this is very important because in some cases you don't want to re-enter everything over and over again with just slightly different parameters. So you can now populate and edit ADQL. So notice that I'm clicking on the box on the bottom, populate and edit ADQL, and notice that all of a sudden this box ADQL query now contains essentially everything that is identical in terms of the search constraints, what was in the table before. All right, so this is something that gives you a sense of how you can actually play with it. Now, what I'm going to do now, I'm exactly at 9:30, so I would like to show you something that is actually sort of a bit more fun. The very specific two cases of plotting a variable light curve of a variable source. Okay, so we're going to pick up a flux history of an active galactic nucleus that happens to be in Challenger Deep Field South. So I'm going to go into edit ADQL, okay, and I'm going to clear the ADQL here. I'm going to clear this guy, okay, and I'm going to enter this particular query that, if you're following along, which is in Portal Tutorial 104.7, and again, I'm basically copying the entry that is in step 1 into the ADQL query, and here we go. So now what you have, do I have a lot of entries in the chat? Now I see that there might be some questions. Can you see, Tina, if there's anything in the chat that I need to respond to?
No, I just copied the query in there.
Perfect. Okay. So now you're probably wondering what in the world is going on with this particular query. Okay, so let me just walk you through this. It turns out that much more efficient way to query the tables, especially the object ID. Again, this is going to be query for the particular target, which is at coordinates of 53.112, whatever, minus 27.684. And I'm selecting very small region. Primarily, the goal for this query is to get something that is called the DP1, from the table DP1, something that is known as DIA object. So the whole idea here is I want to get this object's ID. It's much easier to perform the searches from the catalog using or much more efficient to use the object ID rather than to do it by entering the array index. So I think that you probably have heard that also in Yumi's presentation if you were there. Sorry, Tomislav, you have a question? Sorry? Okay, so the purpose of this, the purpose of this query is basically just to get the purpose of this query is to just get the DIA object ID. And the reason why I asked also for a number of DIA sources is because in some cases you might have an observation that's very slightly off, and we probably do not want to use that particular DIA object ID. We just really would like to use the one with the largest number of observations, and indeed there's 83 observations in that particular DIA object ID. Okay, so let's go back to the query, and this DIA object ID now is going to be used in another query where we're going to actually, it's an ADQA query that we're going to join two tables. You probably have heard about it from Yumi, and I'm going to go back to the DP1 catalogs. I'm going to basically go into ADQL, and now I'm going to clear this particular query, but I'm going to enter another one, and it will be just the one with the DIA object ID that I selected from the previous one, okay? And what I'm going to do is I'm going to join the two tables. One of them is this forced source on DIA object. Okay, this is basically essentially extracting the flags from this particular location, but that particular table does not have the observation time, which is this, it's listed here as X midpoint MJD. That stands for exposure midpoint modified Julian date. Okay, so now I'm going to extract that particular information here, so that the table that will come back, that will be returned on the bottom of the screen, will not only have the observation time, but also I'm selecting the source flags, which is this PSF flags, but also I'm selecting the flags error here. Again, as I mentioned earlier, I'm following the 104.7. So in a case if everything is working for you, you should be able to see the same kind of thing. And notice what's happening here is again, there is a number of bits of information here on the bottom of the table, but the important part is that you have the exposure midpoint and you have flags and flags error. By default, the image on the right-hand side, upper right-hand side, sorry, the plot on an upper right-hand side gives you array as a function of DEC. It's not particularly interesting because it's always the same array and the same DEC since you're studying the same source. So now if you want to plot some kind of quantity against another quantity, you want to click on a little gear here, okay? And I'm going to do this. And that will result in a pop-up table, which in the X, we're going to enter basically the time. Obviously, that's what's of interest here. And in Y, we want to put a flags of an object, okay? And we also want to add error here. And again, notice that interestingly enough, when I click on a table, all of a sudden what appears is what is available there. So I'm going to ask for PSF flags error, and for the chart options, I'll just for the chart title, I will just type something like light curve. Okay, you can put labels of any variety that you wish. Okay, and you can apply this here. Okay, now there's a bunch of observations, bunch of fluxes here, and what I want to do is, of course, those are pointings with filters that there is a pretty large variety of them. So what I'm going to choose here is only a filter I, and I'm going to apply that, and notice that all of a sudden I have just the light curve of an AGN in the extended Chandra Deep Field South with the coordinates that are listed on the bottom as a function of time. So this is actually real science. This is something that I don't know if anybody has done it before, but I think that this is really pretty cool that you can actually get something out of it. So that's at this point, maybe I should stop and ask whether there's any interest. Again, this is the stuff on the upper left-hand side. Since I'm working with catalogs nowadays, it's sort of residual from my previous searches. Okay, so let me stop here and ask whether what I've done is something that you can follow relatively easily on your own. Again, this is all in this tutorial 104.7.
I followed it and it was awesome.
Well, thank you. I personally think that seeing real data and seeing real results from data preview 1 is pretty cool. So now
Aaron has a question about the variability on the same day.
Aaron, frankly speaking, I have not inspected the data carefully enough to know whether this variability is something that is a residual of maybe not perfect background subtraction. Remember that this is commissioning camera. This is not a full survey yet. So if I can be so cagey about the fact that this is awesome, but you know it's maybe not something that you probably want to just rush off and publish. This very rapid variability on a sub-day time scale.
If you zoom, Greg, on the say on that first day where there's a lot of points,
right.
And maybe you could just show how you can like zoom in on those.
Excellent. So the way I can zoom in on those is basically by going into the little gear here, and notice that this is thank you very much. This is actually really great. So let me just do something a little more clear. Notice that what I did is I subtracted 60,000, and now you have the distances, you have the exposure midpoints. So let me zoom in. Again, I'm going to go into a little gear, and again, I'm going to go from, notice that this is, let me close this for a second. This goes from 622 to 625. So let's do this. X minus 6 to 2 and X max is 6 to 5. I think that's correct, that you can actually, yeah. And so let me expand the 6 between 6 to 3 and 6 to 3.5. And probably should have gone to 6 to 3. 6 to 3.5. Okay, so this is the flux measurement from during that very short observation. So is that what you meant, Jeff?
Yeah. I was just thinking it'd be nice to show how you could zoom if you wanted to know if that was a real trend in the one night or something.
That's right. So this is pretty cool that you can do this. Okay, at this point, maybe let me just close all the windows here, and I'm going to do a little bit of cosmology for you for a change, you know. So let me just close all those individual windows. Notice that I can actually return to some of my previous searches by using the little tabs on the bottom. So let me just, once I click on the last one, I will be going into into the particular HIP search and stuff like this. So okay, that's not that important. Let me go back into the catalogs, and I'm going to now go to 104.6. Okay, And so go ahead and switch to 104.6 portal tutorial, and we're going to essentially do the color magnitude diagram of some sources that will be in a region of a radius of 0.3 degree in again in the extended Chandra Deep Field South. Let me just
Sorry, Greg, which tutorial are you working on now? I can get the
104.6.
104.6. Thank you.
Okay, so now I'm going to clear the entry here. So 104.6 is again the title of it is plot histograms and heat maps. So the idea here is that we'll be plotting histograms of the distribution of fluxes of magnitudes of objects that are brighter than 360 nanojanskis, which basically is equivalent to, if I remember correctly, 25th magnitude in both G and R band. Okay, so again, if you copy the ADQL query into ADQL query box here, and that's what I'm doing right now. Again, so what I'm doing here is I'm selecting the G C model magnitude and R C model magnitude, and I want to make sure that I know that those are extended sources. So I'm extracting the G extendedness and R extendedness, and I require that they are equal to 1. So those are extended sources. And again, the region of the sky where where I'm extracting data from is again this 53.0 and minus 28.0 and 0.3 degree in radius. And at that point, let me just click search. Okay. And again, this is working. And notice that what I got now is this HIPS map in a background, and this is just a display. This is not something that we're particularly interested in. We're not going to be working with maps, but the upper left-hand side has the HIPS map that is underneath of the regions of the sky that might have large number of objects. But anyway, so this is of less interest to me. But what I want to do is, again, as I mentioned, there's this sort of slightly annoying always default display on a upper right-hand side, which is array versus deck. Who cares? We're much more interested in for instance, doing the new kind of chart here. So I want to put a histogram here of G C model magnitudes, okay? And again, everything else, so let me just put into chart title to be histogram. Okay, and let me just put this. And this is real data. So let me close this one. Again, this is not of interest. This is real data. This is the histogram of G C model magnitudes as a function of their number in 0.3 degree radius region of the sky of the DP1 of the commissioning camera. So this now is not simulated data, and I think that that's the exciting part for me. So now what I want to do is I want to create a color magnitude diagram. So if you continue with 104.7, okay, you can actually add additional trace here, and you can click on this little plus here. And instead of having a histogram, I'm going to go for the heat map. Heat map is basically two-dimensional histogram when the brightness or color of the point is the intensity, but you can actually plot two different ingredients. So for X, I'm going to do, again, as I have here, G C model magnitude. Okay, so again, very nice thing is I can do this. And here I can plot G minus R. Okay, so there will be G C model magnitude. Now, bear with me. This will turn red when this is, again, another one of the indications of how powerful this portal aspect is. Unless I put something that is valid, it will be colored red, but for the time being, notice when I type the last letter, all of a sudden it will turn black. It means that it's valid, okay? And the color scale will be some kind of default number of bins, and again, I'm going to leave it as a default. You can play around and beautify it to your desire. So let me just label this as color magnitude diagram and just click OK. So notice that what happens is the new screen appears here. Hopefully you can see it is not covered by anything else. But of course you can, at this point, you can just get rid of the guy here. You can actually slide the windows a bit more. So this is really nice. This is real data. This is what we actually see in the commissioning camera. So of course, this is sort of a bit of an advertisement that now you can imagine how much better data we're going to have from long observations of much better calibrated LSST camera. So at this point, I think I'm coming sort of close towards the end of my time, and I will be certainly present here for an hour between 10 and 11 o'clock if you want to have me explain any more about the portal aspect, or do something like maybe create other kinds of plots and so on and so forth. So let me stop here, and maybe I can just leave the screen here, but please do go ahead and raise your hand if so. Let me actually, maybe I can stop sharing screen, then if necessary I can share it again. All right, so let me click on the chat to see if there's any questions coming up from anybody.
I think we've got them all covered. Does anybody, feel free to unmute if you haven't had your question answered.
Yeah, it looks like Lorena has a couple of questions.
Cool.
Okay, Lorena, maybe you can even ask them by unmuting yourself.
Hi, Greg. Yeah, so I was wondering if is it possible to query a sample of sources? Like, for instance, I want to query a sample of AGN and to get the light curves.
I am not sure if it's very straightforward to do the query of light curves of multiple objects using the portal. I have not tried this, but I suspect that you can probably come up with a DQL query for multiple objects. It's just that I'm not quite sure how to do this, but I know it's cumbersome to do it one at a time, but which is what I illustrated here. So I don't know. I probably should get, learn about it and try to get back to you.
Okay, thank you.
Unless anybody else knows. Jeff, you might know, I know it is possible and very easy, relatively easy to do in the notebook aspect, and I think Jeff has done that for variable stars in data preview 0.2. But I suspect that once you have the search for variable objects, again, Jeff, help me out here if you.
Yeah, I can look up which tutorial. We have a tutorial that shows you how to where you can actually upload your table of objects that you want to search, and then match that to, for example, the DIA object table to find the list of matches. So I'll look up which of our tutorials demonstrates that. But yeah, you can actually upload a table and then do the matching.
The key thing is that you have to know the coordinates relatively well measured coordinates for all those objects in a table. But I think that's I recall you've done it for our Lyra stars or some kind of variable stars in one of the BP 0.2 tutorials.
Okay, thank you. And then one more question.
Go ahead.
If I have an AGN, should I use different fluxes, or is it possible to ask for the apparent magnitude? So I mean, are there any corrections done through the reference image to get the magnitude?
Are there any corrections? This is a really interesting question. In other words, is there any automatic dereddening that you can, for instance, do? Is that what you're after, or?
I mean, because if you have a transient, then all the differences will be positive. But if you have an AGN or a variable star, then you have the reference and the fluxes can be either positive or negative. So are there any corrections to get then the correct apparent magnitudes? Because what I saw in the notebooks, it's that the conversion is straightforward. So when you have negative fluxes, it is not well converted into magnitude.
That's a really good question. Yeah, so one of the things that I personally feel it's pretty important is you might want to always work with fluxes, because when flux is negative, the danger of the conversion is that when flux is negative, you get nothing. So the observation gets basically it gets zeroed out or whatever it did. So I think you have I would personally work with fluxes first. Now, as far as you're talking about difference image analysis at this point, I think that there is a way to extract not the difference image analysis flux, but the PSF flux, which is what I illustrated here. So Jeff, help me out. I'm not sure. I hope I'm not confusing things. You can one of
No, I think yeah, what you can do is for example, the forced source on dia object table reports both the difference fluxes and the forced flux measurement on the direct image. And so you have the you could use just the direct image flux, but if you want the difference flux and then just to put back in like a reference flux, like a mean flux, then you could actually get from the DIA object, the DIA object table, you can get a mean flux value
Yeah,
for
this is what
each object.
I was thinking on. Yeah.
I
Yeah, so
think
you could just add that mean flux back in
You
and then
just move,
convert to
you
mag.
just move it to all positive and then you convert to magnitude. Yeah.
right. I think that there's a very nice response from Kathy Vivas. Thank you very much, Kathy, for doing this. She says, Lorena, I think you can use table dp1.force source on DA object to avoid negative fluxes. And I think that that's
Yeah, but I don't want to avoid negative fluxes, but I want to I think the best is was Jeff was mentioning, that you get the difference flux, then you correct it from with the mean magnitude from the reference, and then from that like total flux, you convert it to apparent magnitude. Because in that way it will be all positive.
right. I think Jeff just posted in the chat window.
Great. Thank you so much.
Sure.
Oh yeah, so I was gonna in answer to your other question, Lorena, we haven't converted our tutorial about how to upload a table and then cross match it yet. So the link that I just put in is going to point you to a thing that says coming soon. So we will have those tutorials for how to upload your own table and then cross match it with other tables very soon
Okay.
at the
will be
link
good.
that I gave you.
Okay, thank you so much.
Louise had a question in the chat about plotting the catalog points RA and DEC on an image. And I was poking around looking and I thought, anyway, Jeff, to you.
Yeah, that's
I think you and Greg have better portal food than I do. I think maybe you could show how to overlay the or you probably know as well as I do how to overlay the points on the
Yeah.
images.
Under pressure, I'm not remembering.
I mean, one thing that you can do, or that is always true, is when you do a catalog query in the portal, the window, there are the three windows, and the one that I guess in the default view with the three windows, the one that's on the left has a tab that says coverage, and it's often going to show you that coverage map by default, but if it doesn't, you can just click the little tab that says coverage and it will show you a HIPS map, a deep coed image basically. And any sources that were returned in your search will be overplotted onto that coverage
Okay,
map.
so I go to the HP,
yes,
that pretty
the
color
HIPS
view image, and they should automatically
Indeed.
be there. And that
Yeah,
would be
so I
for,
don't have the portal open, but maybe if Greg still has the portal open, you could.
Yeah, not only I do,
show
but
me.
I actually, what Luis is asking is actually something I probably should have explained. So let me just go and share my screen, and that will be probably quite convenient because it's right on the display. So it's just this guy. So Luis, notice that now we have this this HIPS map with the stuff that's overlaid on it. So now you have those boxes with the number of individual entries there. But if I now zoom in on this, okay, now let me just get a little bit closer. And now notice that when you have less than certain number of entries there, they appear as individual entries.
Great. Wonderful.
That's
Okay, and I
how-
assume that would happen too if I just uploaded my own catalog.
I think that's right. I never really tried to upload catalogs, but I suspect that's right.
Okay, thanks guys. Also, hello. Thanks so much for the
Hi,
tutorial.
see you as always.
Yeah, good to see you, Luis. Yeah, and this also works if you have an image displayed that is in the same region as the catalog that you had searched here. It will also display the points on top of the image. It doesn't just have to be on the HIPS maps. It can also be on an image that you've displayed.
All right, I can probably stop sharing here just in case if there is anything else, any other messages and questions.
This was awesome.
Well, thank you, but I think that this really was for, intended for people who are sort of more of novices, and I hope that there will be others who will try to. And by the way,
I learned stuff.
oh, good. I guess that those are sort of two areas that I've heard questions about. One of them is basically the distribution of brightnesses of objects in the field, and another one was light curves. So I think that we have both. All right, looks like the team is coming back from the breakout. So we're gonna have plenty of time for questions here.
All right, presentation sessions from this morning are done. Thank you to all presenters. Now we start our Q&A session. We go for around an hour or until we run out of questions. There's been a suggestion already, because we didn't get to the Firefly tutorial in the breakout room, that the Firefly tutorial proceed. So could I get a show of hands if I did make a breakout room for the Firefly interactive image display tutorial? Is there interest in having Douglas go through that? A one hand, at least a thumbs up. Yes. All right. Answer is yes, there's definitely interest. All right. Okay, so we'll have that room for sure. And I'm going to make an extra room just in case we need it. And I'm going to open the room so that the Firefly can get started. And we'll do just sort of open Q&A in the main room here once people make their way to the Firefly room if they want to. And if anyone is having trouble getting into that breakout room, I will send you.
Melissa, do we have